Okay, so I hope you saw video 1333 because in that we talked about fractal capacitors and the possibility of harnessing energy from electrostatic forces. And of course that's exactly what I plan on doing. Now, in that video I pointed out a Hackaday project called the Flag Project where they used what was essentially a variable
project that's inspired all of this work, and as you can see it's the flexible circuit wind generator that's available on Hackaday. And what we're interested in is this circuit here. This is the circuit that they used. Now, I don't intend on just copying what they've done. What I'm interested in doing is breaking it down. So, D1, D2, D3, we're going to use microwave oven diodes because they have a high voltage and they've got a low drop. C2, we're going to use a microwave oven capacitor. I'm going to dispense with the load because we're going to measure the voltage change over C2 to show that actually we are pumping electrons, we are generating voltage, and because C2 is going to go up in voltage, we are storing energy. Now C1 is the unique capacitor. It's a three-plate variable capacitor, and the wind flaps this plate in the middle, and that varies the capacitance between the two outer plates. We're going to replace that with an electrostatic generator, a really simple electrostatic generator, and we're not going to connect it to ground either, because all we want is a simple electrostatic generator to show that we're actually being able to store voltage on C2. If we have that, then we have a thing that's working.
A variable capacitor doesn't only have to be two plates like that. We can equally make a disc that rotates, and as we rotate that disc, as a metal sector goes in and out of two other metal sectors, we'll get exactly the same effect of variable capacitor. So I've got some sheet acrylic and I'm going to cut a disc out of it using my ridiculously large hole saw. So let's do that. Okay, and there it is. That's going to be the basis of the capacitor. So let's get that cleaned up and put some aluminium on it. So I've cut myself my big disc, but I've also cut these four little discs because if I try and put an axle through there, what it'll do is just wobble. What I need to do is just build out a little bit with a boss. So I'll glue two discs there, two discs the other side. That'll give me a little bit of a boss. When I drill through that with the 8mm, then the thing won't wobble. So let's glue that on. So that's the disc made with its bosses, and now to turn this into a capacitor plate we need to make that surface conductive, and I've got a bit of aluminium foil here. This is the stuff they use in heating and ventilation applications, and it's just a bit of sticky aluminium foil. Peel it off and stick it to both sides of that disc, smooth it down, and we're going to have ourselves a capacitor plate. So that's the wheel finished. Now I made a couple of uprights out of acrylic and just bunged a couple of ball bearings in them. The only interesting thing to note is right here I've jammed a wire between the holder and the bearing because this sits in there, and of course everything's in contact, so that actually makes the conductor for that plate there. So these extra bits, they're dead easy. They're just a bit of acrylic with some aluminium foil stuck on them. There's two. So here it is all together, and that's really simple. Like I say, that's the disc that we made. There's the two acrylic plates we made. We put it on this little stand here so that we can get it to spin. On the back we've used exactly that circuit that we looked at. So there's the diodes there, another one there, and the microwave oven diodes, and I've connected them up same way as that circuit. For the capacitor in that circuit I've used a microwave oven capacitor, and the only thing missing on here actually is the load, but I've connected a meter. The meter is connected across the capacitor, so if we're able to pump some charge and raise the voltage on that capacitor, then we're storing some energy. So let's give that a spin and see how it does. So you can see I've got that up now to 0.3 of a volt actually, just spinning it by hand. So we are successfully charging that capacitor. That's pretty cool. The cap's got a discharge resistor built in it, so it's going to start discharging again, but we easily got that to 0.3 of a volt. That's actually really quite cool, eh? So this is a 1 microfarad capacitor at 2 kV, and we got it up to half a volt. So not a huge amount of energy stored, but you wouldn't expect it. I mean, we're using aluminium plates from a quite small variable capacitor. I mean, it's probably a couple of picofarads. Well, nanofarads actually, a nanofarad or two, something like that. But it is definitely working. We're definitely able to generate some energy from using just 2 aluminium plates, I mean next to no torque on that, and spinning it. So that flag will obviously work as well. And I didn't like the flag particularly just because it was an arrangement I felt we couldn't work with, where we can work with an arrangement like this and start fiddling on with it. So this is my first step on scavenging energy with capacitors using that circuit in the flag circuit. And of course what we're going to do now is repeat this but with our ink, and then we're going to have a look at those fractal capacitors. So step by step, so we get the idea where we might be going wrong or not. Anyway, that's the first build of this little series, and if you want to give it a go yourself, obviously I've kept it nice and simple, so it's really easy to make out of scavenged parts if you want to give it a go and see whether you can come up with better arrangements and how it works for you. Anyway, I hope you enjoyed the video series so far. Thank you very much for watching, and please remember to like and subscribe.